All right, what's up, everyone? This is 14.3. We are going to continue graphing from standard form. The difference in 14.3 is I'm going to try and graph my zeros, which we're going to use factoring to do. And if we can't factor, then we are going to solve using a table. So just showing you these multiple kind of strategies that we've learned and how they apply to graphing quadratics, especially in standard form. So let's get started here. I've kind of, as looking through the sheet, I'm just going to do 5, 6, 7, 8. Number 5, the first thing I'm going to check to see is, can this be factored? So we're going to take our last number times our first number. There's no leading coefficient here, so there's not going to be any extra work. So that's just 3 on top. We have 2 on the bottom. That's our middle number, goes on the bottom there. And we're looking for what would multiply to make 3 and combine to make 2. So if you think about the factors of 3, we have 1 times 3 and that's it. And we are either going to be able to add them to make 4 or subtract them to make 2. But in order to subtract them, one of these two numbers is going to have to be negative. And we're not going to be able to create a positive 3 if, like, it would have to be 3 times, or 3 minus 1. So it would have to be 3 and a negative 1 to make 2. 3 minus 1 is 2. But we can't do 3 times negative 1 to get positive 3. So for this one, we don't have zeros. This one's not factorable, which means it doesn't have zeros. So what we'll do is continue practicing negative b over 2 times a. So that's the opposite of our b, which means the opposite of 2, which is negative 2, over 2 times our a value, which is 1. That gives us negative 2 over 2, which gives us negative 1. So the first point in our vertex is negative 1, comma, we don't know what the second point is yet. We can find the second point by plugging that in. So y equals a number squared plus 2 times a number plus 3. And where did I get that from? I got this from our original equation over here. Okay, so now I'm going to begin the process of plugging in a negative 1. So I'm replacing x with a negative 1. And then I'm working that out. Negative 1 times negative 1. I'm doing 2 times negative 1, which is negative 2. Bringing my other values down. And then when I evaluate this, 1 minus 2, I'll just break it all the way down. So when I plugged in a negative 1, I got out a 2. And we can plot that point right now for our vertex if we want. Negative 1, positive 2, which would be right here. Our axis of symmetry cuts through our vertex. And so if I have an xy table, negative 1 and 2 are my first point, and I'm going to build 2 numbers smaller and 2 numbers larger. And then remember, so I had this was my red point, my vertex. In blue, whatever I get for this negative 2 in blue will also apply to 0. And whatever I get for this 1 in purple will also apply to this negative 3. So I really only need to plug in 1 blue number and 1 purple number, and I can use it for both. So I'm rewriting y equals a number squared plus 2 times a number plus 3. And I'm doing that in both these boxes. In blue, I'm going to go ahead and use this 0. That seems like a... So I've chosen to use this value to plug in here. I could have also used the -2, but I figured I'll go with the 0. It's going to be much easier. And then same thing, I'm going to use this 1 over here. You could use -3. You're going to get the same values out, but I'm going to use 1. So as I go through and evaluate for my first box, 0 to the second power is 0, plus 2 times 0, which is 0, plus 3. Well, y equals 3. So next was 0, y is 3. That is also true up here. For purple, when I evaluate this, 1 to the second power is 1. 2 times 1 is 2. And 1 plus 2 plus 3 is 6. So when I plugged in a 1, I got out a 6. I can also use that up here. So as I plot these points, -3, 6 in purple is up here, and 1, 6 is right here. In my blue points, I have -2 and 3, which is here. And I have 0 and 3, which is here. And I'll use just black to make my parabola. Okay, so that was just graphing. Not being able to use the zeros, and there were no zeros, and we can tell that we did that right because our graph should cross the x-axis here if there were zeros. So that's what the zeros mean. It means where does our parabola cross our x-axis. Let's see what happens in number 6. I'm going to start with the same thing. I'm going to see if the zeros work. If the zeros work, then I'm just going to find my vertex and maybe one more point. We'll see. So we have 3 on top, -4 on the bottom. So in order to make 3, I can do 1 times 3. And if I had a -1 and a -3, that would make a -4. And so those will also multiply to make a +3. So we do have zeros. So here's what I'm going to do. No leading coefficient, right? No number in front, no extra work. We know that this is x minus 1 times x minus 3. And we're going to set that equal to 0. Our zero product property rule, I guess I don't really need parentheses when I write this, tells us that we can set each equal to 0 and solve. So x equals 1 and x equals 3. And essentially what I did, I said this 0 here, I made that, right? In our original equation, it's y. So if I made y 0, x is 1. I'm going to plot my zeros in blue. So 0, 1 would be here, and 0, 3 would be here. And we could use these to find the first point of our vertex because it's in between. So our first point of our vertex is going to be in between here. So the first point of our vertex will end up being 2. I'll show you how we find it mathematically as well. Right? -b over 2 times a. So the opposite of -4 over 2 times 1. And 4 over 2, which means 2. And that's what we just looked at, right? Visually, we looked at what's in between those two. It's a 2. And that's what we got here. We'll plug that back in. Instead of an x, I'm replacing it with a 2. And then evaluating. So when I plugged in a 2, I got out a -1. That's our vertex. I'll do the vertex in red. So 2, -1, there's my vertex. And then honestly for this, let's look back up at our original. In standard form, our C term, right? So we always label A, B, and C. A, B, C. A is 1, B is -4, C is 3. Our C term is our y-intercept. So if x was 0, think about it. If this was 0 and this x was 0, they would all become zeros to just leave us with our C value. We saw that happen in this equation. When we plugged in zeros, look what happened. 0 plus 0. And that gave us 0, 3, which is right here. So it's kind of the same idea over here. In standard form, we have if x is 0, then we end up with just a 3. So watch how I plot this last point. And again, this is more just 0, 3. These are more just kind of what are the strategies now that we've learned and how do they apply. So if I'm 2 away there, I'm going to go 1, 2 of my dark lines there. I could count all the lines if I wanted, it would be the same, and there's my parabola. So I didn't have to make a table on that one. That one's a nice